Hello, welcome along. It's the Fun Kids Science Weekly, the only show that promises to uncover all of the true secrets lurking around the universe. This week, we'll talk about the classic deadly snake. Do me a favour, right now, in your brain, picture a snake. Yeah, that snake. We are talking about that snake this week. And also, you will not believe that we haven't included it on our Dangerous Dan list. We are writing that wrong this week. Make sure you stick around for that. Also, you can find out why a supergiant star suddenly got cold. And at last, we will figure out what actually happened to the dinosaurs. Plus, I've got your questions answered. Today they're on birds, they're on the mass of the Earth, and also your heart too, and what happens when your heart stops beating. It's on the way. First, let's get into it with one of our favourite geniuses here on the show. This is Professor Hallux.
Professor Hallux's Digital Dental Depository, with support from Philips Sonicare.
To honour great Uncle Halitosis, dentist extraordinaire, on the occasion of his 100th birthday, Professor Hallux is creating a pop-up digital dental depository, an oral health help desk. He's going to see how many questions all about teeth he can answer against the clock.
I think the turbine's nearly up to speed. Ready, Nanobot? It looks like it's loading some devilishly difficult dental doozies.
I'm ready. Here we go. First question. What is a dentist?
Dentists are specially trained medical specialists. They know all about teeth and mouths, how to keep them healthy, and how to mend and treat problems that might arise.
Next question. Why are dentists important?
Well, that's easy enough. It's because teeth are important. If you haven't got teeth, two things start to get difficult. First of all, eating. You'd have nothing to bite and chew your food, and would only be able to eat soup. And then secondly, there's talking. Teeth help us to form different letter sounds. Without them, you'd talk a bit like this.
Strong start as always, Professor. What happens when you visit a dentist?
So here's how it works when you go for a checkup. You sit in a lovely big squishy chair which is adjustable, so it might go up and down a bit. The dentist will then have a look in your mouth and count your teeth. If you've got more than 50, then you may be a crocodile and have to be sent to the zoo. Only joking. The dentist may start by checking to see how many baby teeth you may still have, and if your adult teeth have started to appear. They'll check to see that your teeth meet properly when you bite, and look at your gums to see if they're nice and pink. They may use a probe to examine your teeth and gums. That's basically a stick with a pokey bit on the end. Sometimes they might also take an X-ray to look under the surface too. X-rays sound very whizzy and action-packed, but to be honest, they're nowhere near as exciting as that. It's more like having a photo taken inside your mouth.
Sounds exciting to me. Next up. What happens if the dentist spots tooth decay? That's damage to your teeth from eating sugary food and not brushing enough.
Well, if you have tooth decay, you might need a filling. The dentist scrapes or drills out the rotten part of the tooth and then fills the hole with a special filler that sets as hard as the enamel on your teeth. Dentists are very kind people and make sure having a filling doesn't hurt. They'll probably give you some special medicine and an injection to numb any pain. And when your tooth is filled, you get a big round of applause for being brave. Of course, there's a really easy-peasy way to avoid tooth decay and cavities and fillings and all that. And it's something you should be doing twice a day for at least 2 minutes. Brushing your teeth. That'll keep you smiling and make sure every trip to the dentist is a breeze.
That's correct. And time's up. Brilliant, Professor. Very respectable score there. And lots of data for our digital dental depository.
Professor Hallux's Digital Dental Depository, with support from Philips Sonicare. Find out more at funkidslive.com/Hallux.
It's question time on the show. My favourite part of the show, really, when you turn me into a science Sherlock. You ask a science question that you just can't figure out over on Apple Podcasts. Leave it as a review for the Fun Kids Science Weekly. I'll see it, then I'll do all the digging and get you the answer. This one is from Soren in Texas. Amazing. Soren, thank you for getting in touch all the way there. Soren asks, how do birds survive super high winds? We're talking about storms here, Soren, aren't we? Well, birds sense when a storm is coming. They're aware of tiny changes in the atmosphere, like shifts in temperature, wind speed, changes in pressure, wind direction, and that means they can think quickly and act early to try and stay safe. When there is a storm coming, when they've sensed one, very suddenly they'll eat a lot. They will stuff their face, get loads of fuel in the tank because they'll have to move from their normal shelter very quickly. They might be unsure when they're going to eat again, so they will really cram through the stuff. Then they'll get out of the way quickly and they'll find somewhere new and covered to stay safe from hurling winds. They've also got sharp claws, so they can latch themselves onto branches, maybe tucking against the trunk of a tree or finding hidden gaps inside it. Thank you for that, Soren. Next question comes from Ella and Juliet, who are in Hertfordshire, a little bit closer to where I am in London, who ask, how do scientists weigh the Earth? This is a mega question, so hard for me to even try and touch on. The easy answer is scientists figure out the mass of the Earth, because that's what you're talking about. It's not really the weight of the Earth, it's the mass, how large, how much stuff the Earth actually is. The Earth's mass is 6 times 10 to the power of 24 kilograms. It's a huge number. And the way they work out how much mass it is basically an equation. They can hardly sit the Earth on a scale somewhere, can they? Where would you fit that scale to start with? So they figure it out with an equation. And to do that, they work out how strong its gravity is. Now, they use the equations worked out back in the day when Isaac Newton did them. Scientists are able to figure out how quickly an object drops to Earth. So by doing that, they can figure out how strong the Earth's gravity is. When they know how strong the gravity is, they can work out how large the Earth is, because certain sizes attract other sizes in a quicker way. That's how they figure out how big it is. And if you want the equation, you can write this down. The equation that they use is this. Force equals gravity times the mass of the first object times the mass of the second object divided by the square of the distance between the objects. Would be easier if they used a scale, wouldn't it? Ella and Juliet, they work it out using a big, complex Isaac Newton-y equation, all to do with gravity. Thanks for that question. And lastly, we've got Josh, who is 8 years old, who asks, how long can you live without your heart beating? It's a strange one to answer, really. A strange question, a strange one to answer too. You see, when your heart stops beating, it stops pushing blood around your body. Blood is important because it carries the oxygen in it to feed the organs and cells and help them work. They need oxygen. Your brain can last about 6 minutes after the heart stops. And then without oxygen, the cells up there will start to die off. Your brain needs fresh oxygen. You know this. You know when you hold your breath for a little while and you start to go dizzy? That's what's happening. It can't be starved of oxygen. But it's weird. Sometimes hearts can be restarted up to 45 minutes after they've stopped. And people have been brought back alive and well after that. So it's kind of a grey area, Josh. But, you know, your brain lasts for 6 minutes, more or less, without your heart beating. Thank you so much for the question. If you've got something sciencey that you want answered on the show, you need to leave it as a review for us over on Apple Podcasts. It's the Fun Kids Science Weekly. Now, imagine this for a sec, right? You're an astronomer. You've discovered a massive star in space. You start looking at it, and then just one day, it disappears. It goes somewhere. You don't know where. What do you do? Andrew Allan is a PhD student in Professor Jose Grove's astrophysics group in Trinity College, Dublin, and he's trying to figure that out himself. It's happened. Andrew, thank you so much for joining us.
Thanks for having me on.
Now, what were the first signs that this star might be there? Before it had gone missing, when did scientists first become aware that this was up in space?
Yeah, so there's a lot of spectroscopic observations going back from 2001 until 2011 of the galaxy that the star itself is in. So the galaxy itself is quite interesting in that it has a lot less metals than we would normally see in galaxies. So we were able to detect, well, the previous observations showed the the possible signature of a very massive star with a very strong wind in this galaxy. So these observations went from 2001 until 2011. So what we wanted to do was to re-observe the star, which we did in 2019, first in August. But when we did, we noticed that the signature that was in the previous observations was no longer there.
So do you mean you're not actually seeing the star? What you're doing is you're almost sensing its echo. You're getting the trace that you know that it's there.
Yeah, exactly. So the star, it's such an extreme star. It has it's what we call a luminous blue variable, and it has a very strong wind, which is constantly ejecting mass from the star. And we're able, because this wind is so fast, so our models predict roughly 1,000 kilometers a second, and we're able to detect the presence of this wind, which is how we infer the presence of the star.
So then what do? You've gone there to observe the star. You can't get the traces that you normally know when you are looking at it. How do you go about trying to detect where it's gone?
Yeah, so after our first observation, we were very, very excited to not find the signature of the star. However, we wanted to make sure this was the case. So the conditions that the first observation was taken on wasn't completely perfect. So we wanted to double check, and we done this again using the same telescope. So for the first observation, we used what's called a very large telescope in Chile, which is the European Southern Observatory's telescope. And with the second observation, we decided to use the same telescope again, this time using a different part of that telescope called X-shooter. And thankfully, this backed up the previous observation, as the star signature was again absent.
Firstly, I love the fact that there is a telescope called the Very Large Telescope. I'm a big fan of that naming policy.
Yeah.
So what are the first impressions that you've got of where the star may have gone? What are the very first ideas that you're having when you can't sense its trace anymore? What's going on in your brain, science-wise, of what might have happened to it?
Yeah, so our team considered a number of scenarios, and we decided to narrow it down to two main ones. So the more interesting possibility is that the star collapsed in on itself, becoming a black hole. And this is known to happen for stars, but usually, especially the massive stars like the star we consider here, but usually there's a very bright explosion detected while this happens. However, this wasn't detected for our star, which makes it quite interesting if this is the case. Another scenario we propose is the star was going through quite a giant eruption during the previous observations. However, this eruption then ended, causing it to become less bright. As well as this, it would be emitting a lot of material, which could form a dust around the star. So a big dusty shell would surround this star, and this dust could partially block the light. And this could also lead to the disappearance of the star.
Now, it's a strange one, Andrew, because I do this podcast, which is quite big all around the world, but yet still the idea of time and space, it warps my mind. Can you just talk me through? So this, it's suddenly disappearing, the effects of this. When would that have happened? Is that happening right now? Has it actually happened, quite a long time ago because of the time that it takes for us to sense what's going on up there?
Yeah, that's a very good question. So this galaxy is really distant. We use a unit of measurement called a parsec, but an easier way of understanding it is in light years. So the light from this galaxy would take 75 million light years to get to us, which means what we're seeing now would have happened this long ago.
And what happens next? You've got these two ideas, these theories of what might have happened. How are you going to figure out what has happened to it?
Yeah, so our team are very fortunate in that we're going to hopefully get to re-observe the galaxy, this time using the Hubble Space Telescope. So Hubble has previously observed the galaxy back when the star was present. So in a study which will be led by Professor Nathan Smith from the University of Arizona, we'll get to re-observe using Hubble now that the star is vanished, and hopefully be able to confirm its disappearance first of all, but hopefully get some clues as to why it happened.
What does the presence, or now disappearance, of a star, what does it teach you about the universe? Has anything... Can we learn from the fact that it's up there? Does it change the way that we view everything in the universe?
Yeah, so massive stars in particular are important for a lot of the elements we see in the universe. So elements such as gold are produced in the supernova explosion. So we're very interested in how these stars end their lives because they produce such important elements for the universe.
Amazing. I just it's such a mind-blowing story. Andrew, listen, thank you so much for joining us on the Science Weekly.
Thanks very much for having me on.
Now, this week's Dangerous Dan is all about one of the most deadly beasts on the planet. A beast that is so deadly, I cannot believe we've not put it on this Dangerous Dan list so far, so we're righting that wrong this week. Here we go. The Indian Cobra lives in Asia, roaming around Pakistan and Sri Lanka, and obviously India. It can grow to 6 foot long. It's about as long as your dad might be tall. And it is the classic snaky looking snake. Imagine in your head an evil snake. That's what this snake looks like. They're the ones that you see snake charmers usually trying to charm. They're greeny brown with some black marks, maybe a diamond on its back. They've got the big hood coming down from its head. And it's a species that inflicts almost more snake bites than any other snake out there. Its bite causes severe pain, swelling, paralysis, and if you're untreated, you can be dead in just 15 minutes. Now, a big problem with the Indian cobra is that it doesn't just stick to the wild. In those countries, you'll often find them hunting near houses, which means they meet humans a lot, and an Indian cobra meeting a human doesn't always end well for either of them, and it earns it a place, finally, on our Dangerous Dan list. It's time to catch up with the Thunderbirds now on the show. This is from another one of our podcast series, Thunderbirds Our Go Mission to Mars. You can listen to it after you're done with this, however you found this episode, and you can also listen along over at funkidslive.com, our website. In every episode, we're teaming up with KO and Brains, two of the Thunderbirds from International Rescue, and we're heading on a mission to the Red Planet.
5, 4, 3, 2, 1.
Thunderbirds Our Go Mission to Mars.
So, I'm with Brains and KO on the world famous but top secret Tracy Island. They've been helping me learn pretty much everything about the ExoMars mission and Rosalind the rover. Thanks, guys, and Max, of course. Oh, do you think there's time to check out Thunderbird 1 on the launch pad? Maybe go for a ride? Try on a uniform?
I'm sure we can give you a tour before you go. But we're not done yet.
You mean there's more?
Well, we've explored Rosalind the rover and her very exciting experiments to look for signs of life. But there's another important part of the mission, and that's on the surface platform from which Rosalind will begin her travels. Take a look. Like Rosalind, the surface platform has been given a name. Its Russian designers have called it Kazachok.
Kazachok means Little Cossack, which is a lively kind of Russian folk dance.
Sweet! Although it looks like a pretty serious piece of equipment, as big as a car.
And nearly as heavy. Once on the Martian surface, Rosalind will drive off the Kazachok platform to perform its scientific investigations. The Kazachok will remain stationary, but it will get to work too, to find out more about the Red Planet.
Its first priority will be to take really good images of the landing site so that Rosalind can safely move onto the planet's surface. But that's just one of a whole bunch of experiments it will do. Isn't that right, Brains?
Correct. Kazachok boasts over a dozen instruments, taking a whole variety of readings. Here are just a couple. This instrument is called LARA. It will undertake lander radio science experiments, taking measurements of the rotation and orientation of the planet by monitoring differences between Mars and the Earth.
That means how Mars spins and in what direction. Things like changes to the polar caps can affect the planet's rotation. They provide clues about geological movements, things that are going on that we might not be able to see.
And this gadget is called Habit.
A good habit, I hope.
It's a shame Gordon's not here. He's quite the joker too. Not that kind of habit, but definitely something good. Its name reflects the things it will test: habitability, brine, irradiation, and temperature. It will measure these on both the planet's surface and in its atmosphere.
Other instruments will measure pressure and humidity, seismic activity, UV radiation and dust, the magnetic field and plasma environment, and, importantly, the gases in the atmosphere.
Didn't you say before that methane is one of the gases we're interested in?
That's right. It's a biomarker, or a sign of life, either now or in the past.
That's a lot of work.
It really is. And aside from biomarkers, it means we will collect a great amount of fascinating new information about Mars. And as the measurements will take over 12 months, we will be able to get a picture of how things on the red planet change over time.
Sounds like the surface platform is working even harder than Rosalind the rover.
Like most space missions, it's more of a case of working together.
Same as you guys helping me out, although I don't think I'm as smart as the rover or the surface platform.
I don't think anyone is, except for brains.
Well, perhaps with Max to assist.
Thunderbirds are go, mission to Mars, with support from the UK Space Agency and International Rescue. Find out more at funkidslive.com/space.
We've got big breaking news that is 100 million years old thereabouts to start this week's Science in the News. Asteroids were definitely to blame for causing the dinosaurs to go extinct. I know you probably thought that anyway. Scientists often did think that, but some believed that it was also a series of volcanic eruptions that blocked the sky with the ash and plunged the world into winter. But researchers from universities in the UK say that they've done studies and tests, and only an event on the scale of an asteroid impact could have created conditions and plunged the Earth into a winter that could make the dinosaurs go extinct. So finally, millions and millions and millions of years later, we've sorted out that one. Also, astronomers say big cool patches on a supergiant star close to the Earth were the reason that it dimmed last year. The red giant called Betelgeuse dropped to 40% of its normal brightness last year, which surprised scientists. There was talk that it might explode into a supernova, but now experts believe that cool spots, like sunspots that we see on the sun, blackened it out a bit and made it seem darker. And finally, fruit farms in the UK could use robots to solve a work crisis. Hiring staff who are experienced has been a challenge for the farms, as jobs are in a bit of a state due to lockdown, but a robot that was trialled last year ended up working significantly faster than human workers, and they're hoping it could be used to help out from now on. And that is it for this week's Science in the News. Thank you so much for giving us a listen. Remember, if you've got a sciencey question that you want answered on the show, you need to leave it for me as a review for the podcast over on the Apple Podcast Store. I'd like a few more, so head over to the Apple Podcast Store, find the Fun Kids Science Weekly, and let me know your sciencey questions. It's also one of the best places that you can hear all of our brilliant series that we've got. They're not just science ones, we've got history ones, we've got ones about roads, we've got ones about trains, all sorts on there. You can find them on the Apple Podcast Store. Wherever you get your shows from, Google, Spotify, they're on the free Fun Kids app and at funkidslive.com. And Fun Kids, we're a children's radio station from the UK. You can hear us all over the country on your DAB digital radio. A lot of words, I'm sorry. Also on the Fun Kids app, and as always at funkidslive.com.